Hello everyone, this is the final update on the Falcon Heavy test flight's mission target. There will be more videos on the Falcon Heavy flight and the vehicle in general, however, concerning the payload and the target trajectory, this will be the last update on what we know and what has changed. Of course, mission goals are threefold, as they are always twofold for a reusable Falcon launch. The main goal of this being a first test flight of a new rocket type with a basically dummy payload, the main goal is of course to simply test and study the rocket. The usual primary goal thus becomes the secondary goal, and the usual secondary goal thus becomes a tertiary goal, with the main goal being the main priority and so on. The secondary priority, which would be the first priority for any normal Falcon launch, is of course the payload delivery to the target trajectory, which would usually be setting any payload or satellite into the target orbit. In this case, it's setting the Tesla Roadster onto a Mars transfer orbit, and the tertiary goal, which would usually be the secondary goal, is to land the Falcon 9 first stage for reusability, which in this case is again a bit more complicated because we have three first stages that will land and not actually be reused. Some of them are not even certifiable for a further reuse, but hypothetically they could be recovered and reused. They will be recovered and examined and then probably be put on display. As for the payload and destination orbit, there has been a bit of an addition to the Tesla Roadster. During the last check on the Falcon Heavy before finally raising it for launch, an empty or dummy field, there hasn't been a precise release on that, SpaceX flight suit has been placed on the driver's seat of the Roadster. Additionally, there is communications and tracking equipment in the Roadster, as well as a copy of the Hitchhiker's Guide to the Galaxy in the glove box. The Roadster's audio systems will be playing David Bowie's Space Oddity, although how exactly that is going to work is another question. Now, there is no sound in space, but of course the speakers can still move. There just won't be any way to hear them, although there's not anyone around anyways. Although potentially they might also send it out over radio. The destination orbit will actually not be a current transfer trajectory to Mars, rather it will be a close Hohmann trajectory onto the Mars-Sun orbit, so the car will deliberately miss Mars. Since the transfer orbit and Mars' own orbit have different and non-fractional orbital periods, it will eventually probably get pretty close to Mars once in a while, though not according to the transfer windows that you would expect of the Hohmann Earth-Mars transfer, since Earth itself is at that point also drifting off with a different orbital period. The speed needed to actually reach that transfer orbit is actually not much higher than that needed for a normal escape trajectory, which would be 11.3 kilometers per second of orbital speed relative to the center of Earth. Although the Hohmann Delta V to get from Earth's Sun orbit to Mars' Sun orbit is 8 kilometers per second at the Earth orbit burn, since there's a few mathematical ways to explain this from different perspectives, but basically due to the conservation of energy and kinetic energy being proportional to the square of velocity, if you're already going at some speed that is slowing down by gravity as you are on an escape trajectory, if you just add a little bit more speed, that will translate to a much larger speed as you leave. You can essentially use that square kinetic energy equation and see how much energy is left over after expending the energy needed to escape Earth. Since you are also moving away from Earth faster, gravity actually has less time to slow you down, and so a lot of speed is left over, and if you just add 2.5 kilometers per second to these 11.3 kilometers per second, so if you accelerate to 13.8 kilometers per second, after escaping Earth you'll actually not have 2.5 kilometers per second left, but 8 kilometers per second, which, if you time that burn correctly, as I've explained in my launch window analysis, will bring you onto a Hohmann transfer orbit to Mars. And since this is actually a time where you're pretty much going at the periapsis of the Mars orbit, they're actually getting away with even less, and so above 13 kilometers per second is the target velocity, and while the car will not actually reach Mars, let alone land on it, Just for fun, someone asked what the acceleration of a Tesla would be on Mars, how quickly it would be able to get from 0 to 60, and well, actually that would take longer than on Earth, since the force needed to accelerate a car forward isn't really depending on gravity, but gravity is necessary to gain traction, and so on Mars, with its less than 40% Earth gravity, you will have less than 40% Earth traction. That is of course also assuming a good ground, so basically a racetrack on Mars. And traction is of course not the only limit, but while motor power does get limiting, especially as you approach higher speeds, traction is quite a bit of one factor limiting the acceleration of a roadster, and so on Mars it will actually take almost 3 times as long to get from 0 to 60 as on Earth, so some 5 seconds probably. That is of course a purely hypothetical for fun question, as this roadster will not land on Mars. And while as an electric car it has quite a big electric battery compared to other cars, even that will probably be drained just by electronics and radio communication and playing David Bowie by the time the car could get anywhere near Mars. As for updates on the current launch conduction, the Falcon Heavy is now being rolled out to the launch pad and raised vertical for the final time, at least if the launch goes by schedule. If it gets scrubbed again, which is hypothetically still possible, although at this point actually eventually quite unlikely, it may of course get rolled back into the hangar and re-examined. Now of course for the actual launch criteria, since this is a test flight and the main goal is testing and learning more about the rocket, weather and lighting conditions have to be rather good, since not only does the rocket launch itself have to not be impeded by the weather, but you'd also want a good camera view of the rocket. You want to collect as much data as possible, and so the tracking cameras need to have a constant line of sight with the rocket. Now they're probably not going to scrub the launch over 1 or 2 tiny clouds, but the sky should be mostly clear and the sun should be up, which may also be one limiting factor among others on the launch window itself. The lowest priority goal would then of course be the recovery of all 3 first stages after landing them, although actually with the main goal of testing and examining the rocket, this might even become a bit more important than the payload delivery, since if anything goes wrong, or even if anything goes by plan, or if a tiny bit goes a little bit unexpected but it all works out, or even if everything goes exactly by plan, you'd want to examine the actual flight hardware if you can to learn more, and so recovering it would be quite useful. The left and right booster core will return to the launch site or next to the launch site and land at landing pads on Cape Canaveral, while the center core will go on and slow down and re-enter the atmosphere and land on a drone ship in the Atlantic. So this was my final update on the mission goals of the Falcon Heavy launch. I am still doing further videos on analysis and risk prediction and a bit of technology explanation as well as aerodynamic simulation, and then of course the actual live coverage of the launch, which I will comment, as well as some after analysis whether the launch actually succeeds or not, although being a test launch, in a way the launch will be a success either way. If it actually succeeds to launch the Tesla and we have a new rocket type, or if it goes wrong, then at least we know that something has to be improved, and then we have a new rocket type a little bit later thanks to the information gained on this launch. If you have any further questions regarding the Falcon Heavy launch, or spaceflight in general, or the physics related to it, I am always open for any questions, and of course, as always, thanks for watching.